Today we're going to learn about optical illusions. So what is an optical illusion?
Optical illusion is something that tricks you into thinking it's something different.
So if you thought she was right side up, that was an illusion.
She was actually upside down, just like me.
So you obviously know that my 7-year-old is way smaller than me. But right now, the way that the position of the phone is in comparison with where we are, I seem like I'm smaller. If I go closer to her, you can tell that she's obviously way smaller than me. This is an example of an illusion. Because of the position and the angle of the camera, or the phone in this case, I seemed like I was way further away, and she seemed like she was huge. So this is similar to when you guys take selfies and different angles make you guys look better. That's like the position and angle of things will give a different illusion or a different way things look. So if you look at these two boxes, which one looks bigger, 1 or 2? In the chat box, you can write your answer. Give me a second. All right. Most people would say this box. However, if you bring them closer to the camera and put them at the same exact angle, they're actually exactly the same size. By having a look at these two boxes, which do you think is bigger? 1, 2, or are they the same? So again, write in the chat box which do you think? If you said they were the same, you were wrong. If you said 1 was bigger, you were right. So 1 is significantly bigger than 2. But because of the positioning...
A magic trick.
You've seen an illusion.
You've seen an illusion. Magic trick.
Voila! Where did it go? It disappeared!
Number 10. The Hermann grid illusion. This illusion tricks your mind into believing that the white dots at the intersection of the squares are shifting in color. The dots appear to change from white to dark gray as you stare at the illusion. This optical illusion leads you to believe that there are 3 circles and 2 triangles. But in reality, there are no triangles. There are only incomplete lines. Italian psychologist Gaetano Canizza discovered this optical illusion in 1955. The illusion uses one of the laws of perceptual organization called the law of closure. We tend to perceive pieces of objects as part of a whole when they are grouped together. Therefore, we close the gaps in the objects to try to make the image cohesive. Our brains are essentially closing the gaps and making triangles out of this optical illusion so that we can make sense of the picture. Number 8. The lilac chaser. This crazy optical illusion, also known as the Pac-Man illusion, has to do with something called negative retinal afterimage. For this optical illusion to work, you need to stare at the black cross in the center of the circle for about 20 seconds. After about 20 seconds, you will start to see a green circle moving through the lilac ones. The green circle will start to erase the lilac circles. But as soon as you shift your eyesight, you will see the lilac circles again. The hues of the lilac and green circle are complementary colors and exist on a neutral background. With time, our brains integrate the images of the circles until we see only one object moving around, the green dot. The lilac dots are, of course, still there. Our brains just refuse to see them. Number 7. The Ponzo illusion. In this popular optical illusion, called the Ponzo illusion, 2 lines that are the same length appear to be different lengths. The line that is closer appears to be shorter than the line that is further away. Number 6. The Poggendorf illusion. In this illusion, the blue line on the left appears to be lined up with the black line, whereas the black line on the right appears to connect to the red line. However, the lines in both pictures are exactly the same and are connected in exactly the same way. The only difference is that the rectangle in the image on the left is a darker shade and blocks out part of the lines. Number 5. the impossible trident. At first glance, this optical illusion may not look like much. There appears to be 3 prongs that connect into 2 at one end. But the more you look at this illusion, the more impossible it seems. In fact, if you stare at it long enough, the lines become disorienting. Number 4. The curvature blindness illusion. This fairly new optical illusion was discovered in 2017 by experimental psychologist Kosuke Takahashi in Japan. The lines in the white area and the black area appear wavy or curvy. But to most people, the lines in the gray area appear both wavy and zigzagging. Like most optical illusions, though, you are seeing something that isn't actually there. Number 3. The Ames room illusion. In this mind-blowing illusion, 2 people are standing in the same room, but one person appears to be much larger than the other person. However, the 2 people are actually very similar in size. The illusion is named after the Ames room in the Villette Science Museum in Paris. The picture was taken there and then uploaded to social media. But the illusion has nothing to do with the people in the picture. It has to do with the size and shape of the room. The room appears to be square-shaped, and the 2 people appear to be standing in the same depth field. However, the room is trapezoidal-shaped, so the man in the picture is standing much further back in the room than the woman is. This is a useful optical illusion, and it is often used in movies. Number 2. My wife and my mother-in-law. This optical illusion was drawn by British cartoonist William Ely Hill in 1915. It has since become one of the most famous optical illusions of all time. And although there are other optical illusions where 2 different pictures or images can be seen, My Wife and My Mother-in-Law actually reveals something about the viewers. Viewers either see an old woman, the mother-in-law, or a young woman facing towards the back, the wife. Number 1. Ninio's extinction illusion. If you have seen this image before in social media, you're not alone. The Ninio's extinction illusion has claimed social media fame as viewers try to sort out how many black dots there are in the picture. The picture is comprised of a grid of vertical, horizontal, and diagonal lines. In the picture, there are 12 black dots at various intersections.
Now we're going to travel back in time to look at some art by the artist MC Escher, a Dutch graphic artist from the early 1900s. He is known for using optical illusions and tessellations in his artwork. If you're familiar with the brand Supreme, they've actually featured a lot of his work on their products. So you might know him without even realizing you knew his work. Escher's work was inspired by math, and he was recognized by famous math guys and scientists all over the world. He's most famous for his impossible drawings, in which he created these environments that appear to make sense, but obviously don't in the real world. He warps reality. In his waterfall feeding waterfall, the water goes upwards instead of downwards. The hands drawing hands, and then his dragon literally eating itself, but in a distorted way that doesn't make sense. His buildings kind of have stairs going upwards into ceilings and then into basements, and they just don't make sense whatsoever. So if you look at this video, you can see that Escher's work so this is an animation of one of his works. So someone brought his work to life. So you can really see how they don't make sense in the real world. Like how he kind of defies gravity and what is normal, or what we perceive to be normal. So twist reality. He's also known for his tessellations, closest to what we're doing in class now. So they deal with positive and negative space, meaning white and black objects. So tessellations are actually a math term where you take shapes and kind of fit them into each other. So if you look at this right now, what do you see? Go ahead and write it in the chat. This is focused on negative space. So the negative space is the space around an object where the object counts as positive space. This, you can really see it in this picture where you see the face versus the vase. So the face would be the positive space and the object is the negative space, and the space around it is the negative space. So what we're doing in class, taking these black and white images, so how we're coloring every other image, that's dealing with positive and negative space, which we'll talk about again in our next video.